Okay, hi everyone. Today is our lesson 5, and here's our past recording, lesson recording if you want to look through it. So here's our YouTube channel. It's called IB Max Nepal, and you can search it up. So today our first question is, who are the most influential or important famous people that you know of? It could be like from history that you learn in the history class, or it could be recent, like the famous people you know. Feel free to type in the chat or speak out loud to share your idea for it. Vincent, do you know any influential, or do you have a most famous people in your mind?
Oh yeah, of course I do. Personally, I really like Andrew Jackson because he's really funny.
Mm-hmm. Yeah, Newton. Definitely Da Vinci. Da Vinci. Do anyone else want to share? Alan, do you want to share your famous people?
I find Gandhi pretty cool. He did some peace stuff, and yeah, he just like broke the caste system, which like segregated a lot of people.
Mm-hmm. Sabine, do you have a famous people you want to talk about? Or you can type in the chat. Okay, feel free to put more people in the chat, because as we mentioned before, some students interested in learning about the life story of the famous people. So we can collect this idea and we can talk about the detailed life story they have in our future lesson. So moving on. So today, so like last week, we collected a lot of response from what you all want to learn. So one of the famous one is, popular one is computer and computer science. Yeah, so today we are gonna also learn about computer science and a little bit of math beside our history class. History class, we're gonna learn about personal history. Yeah. So our next question is, do you know what a programming language is? If so, what's your favorite programming language? And yeah, feel free to type in the chat. Like for me, the programming language, I'm not that good at programming, but the one I start from is definitely like the basic block language, like Scratches, if you guys like the little cat, if you guys played it before, and then move on to a basic Python and then Java. So I think that's the only 3 that I know. Okay, it's okay. We are gonna learn about some today. Wacom, do you know programming?
Much programming. I've only ever like used Scratch, so yeah, not really.
Okay. How about Juliana?
I don't really know much either. My brother uses Python, so I guess I've seen that.
Okay, sounds good. Anyone else want to share? Okay, so we are gonna start our lesson now. Oh yeah, here's the overview. Today we are gonna learn about one of the language, which is called C++. and then we are going to learn about some basic information of it. And then we are moving on to some interesting historical figures in history. And then we have some math. Okay. Okay, I guess some of the teacher for programming is not here, but so I'm gonna take over some.
Or should I do the whole thing then?
Yeah, could you?
Okay. Hello, everyone. My name's Vincent. I'm a sophomore, probably like some of you guys. I've been programming for like many years now. I can do like multiple languages. And yeah, so I'll be teaching you guys computer science today. So computer science is like a very broad subject. There's like hardware, software, stuff like that. But we'll be mainly focusing on like programming languages. Um, yeah, so programming languages is probably one of the most important things in computer science because a lot of machines and like computers and whatnot, they all run on code. So yeah, and today there's like many different types of programming languages. We can go on to the next slide. So yeah, today there's many different programming languages. These are just some of them, and different programming languages do different things. So we have Python, which is a lot of the language that most people start on. Like most people who begin programming first use Python. It was first made in 1991. And yeah, it's a really easy code to understand. And then second language we have here is C++. That one originated in 1985. It was actually originally C, like the original language C, but then they kind of improved it and made C++ out of it. C++ is probably like one of the most commonly used languages because it's really good at solving problems. And then we have Java, which is like an even more improved version of C++, I guess. Oh yeah. If I'm going too fast or if you have any questions, you can just like raise your hand or say something. And yeah, Java is also like a really user-friendly or like beginner-friendly language. It's really easy to understand and learn. And yeah, and the bottom languages here, we have HTML, CSS, JavaScript. These ones are all used for building websites, whereas like the top three are used to solve like kind of more like math related problems. So yeah, next slide, please. Okay, compilers and IDE. Well, when you want to write code, you obviously have to have a place to write it, just like how when you write an essay, you have like a Google document or like a piece of binder paper to write it. IDEs are like the place where you write code. So on the bottom here, we have many like different IDEs that you can see. Some of them have names, some of them don't. Like one of them's like PyCharm, which you can see the name of. That one's the most commonly used one to write Python. So a lot of people who use Python probably write their code on PyCharm, because yeah. And then the blue bow tie looking thing to the left, that one, I use that one quite frequently. That one's called Visual Studio Code. It's a pretty good IDE. You can use it to like write many different languages. And yeah, okay, a compiler says here, compilers are computer programs that translate programs written in one language to another. When we program using a modern programming language, for example, Java, its compiler translates the code we wrote into a lower level machine code that computers can understand. Okay, that paragraph there is probably like very confusing for you guys, so I'll simplify it a bit. Basically, when you write a code and you want the code to, when you want your code to give you a result, you have to basically like give it to your computer to run the code. Like, I don't know if you guys have heard of like running code, but yeah, you have to basically run your code in order to like get a result, right? Well, compilers are like when okay, so I get a bit confusing here, but like computers can't directly understand the code you write in English words. The compiler there is kind of to translate what you wrote into binary, which is like 0 and 1s, into something that, or like into something that the computer can understand, and therefore like run your code and give you a result that you want, or maybe a result that you don't want. But yeah, that's basically what a compiler is. It basically translates your code into something the computer can read. Next slide, please. Next slide, please.
Oh, it's updated on my screen, but
Oh, okay. Maybe it's just a bit laggy.
Replik right now.
Okay. Replit, maybe you saw the image earlier, maybe you forgot, but it was on the bottom left corner of the last slide. This is just another IDE, and it says here, most IDEs are applications that have to be downloaded or purchased. However, there are also online IDEs. A popular one is Replit, formerly repl.it. This online IDE supports over 50 programming languages and allows you to write programs and develop software simply on its website. Okay, so guess what's special about this is that it's online. Like previously I named some like PyCharm, Visual Studio Code. Those ones are all like apps where you have to download on your computer in order to like be able to use them and like code. Or like you can't just like for the previous one, like let's say PyCharm or something, you can't search up PyCharm on the website and like code it there. You have to download an app. But I guess Replit is where you can just like search it up in your website. I mean, like on let's say Google Chrome or something probably, and you could probably like code there, and that's pretty neat because I guess it saves you space and download time. Okay, next slide, please. Okay, now we're gonna actually talk about actual programming. So the language I chose to like teach you guys is C++. C++ is not actually that hard. Like it's one of the most commonly used languages. So if you guys can learn C++, you guys can pretty much solve any most problems that aren't like, let's say, web design related. Okay, so we start with the basics. Variables. Can I get a show of hands, Zoom hands, if you know what a variable is? Let's say from math or like any other place. Like I don't know if you guys can raise your Zoom hands, but let's maybe try.
Yeah, I think Zoom hand is on the
It's in
bottom
reactions.
of the
Like
reaction. Like,
if you look down, there's like reactions, and then
mhm.
you can press raise your hand.
Or you can type in the chat, say, yeah, I know, or no, I don't know.
Yeah, you can also type yes. Okay, it's fine if no one like. Which language is easy? I mean, it sort of varies, but let me just like say in general, Python, Java, C++ are all easy because they're kind of like the basic languages that most people would start off with. Because most languages, you'll find out in the future. Yeah, no, but like even if you're not professional, it's like most languages, they're like their foundation is the same. So as long as you learn like the basics, you could basically code in any language. Okay, so variables. A lot of you probably have seen variables in math. They're the exact same thing in programming. A variable is like a letter or maybe a word or something, and it holds a value. So variables in programming can hold a number, a letter, a word, a sentence, or even like true or false. But like in math, you can only hold a number because it's math. And then what's special about variables in programming that are different from math is that all variables in programming have to be defined by a data type. In math, you don't have to define a variable because it's guaranteed to be a number because math only deals with numbers. But in programming, there's like, you have to also deal with like words, letters, and other stuff. So your variable has to be like flexible and it has to be able to like hold different type of data. Okay, next slide, please. Okay, so what is a data type? A data type defines a variable or like a method. Well, we won't deal with methods for now. So there are many data types, but like I said, they're pretty much standard throughout all programming languages. There are 8 primitive or like basic data types, and the 8 are byte, short, int, long, float, double, boolean, and char. String is not actually a primitive data type, although you'll see string a lot in the future and it'll be really common. String is just char but longer. String just holds a string of words or letters. Well, Scratch, I wouldn't actually recommend Scratch because Scratch deals more with logic rather than code. So I guess you're going to learn the logic behind code maybe, but it doesn't actually teach you how to code. So int, long, float, double, byte, short, they all deal with numbers. They're all like your math variables. They hold numbers. Char is short for character, as in like a letter, right? Chars are special in that they only hold one letter. It cannot hold more than one letter. So if my variable is holding A right now, it can only hold A. It can't hold like A and B at the same time. It's a char or like a character. Bool stands for Boolean. I don't know if you guys have heard of Boolean before or not, but Boolean is like a logic concept, and logic generally deals with true or false. So variables that are defined as Boolean hold either a value that is true or is false. So that it can't be any other thing. It's just either true or false. Okay. Hey, yeah, nice. You've used it before. Okay. Then it'll make your programming life easier. Okay, floating point data types. C++ uses scientific notation to represent real numbers. So 75.924 would be represented as 7.592400E1. E, I'm pretty sure, just equals 10 times 10 to the power of something. So basically what that means is, here we have 75 point something, right? In scientific notation, you can only have one number in front of the decimal place. So therefore, you have to multiply the scientific notation number by 10 to a certain amount in order to get your actual number. So let's just pretend this was like 76 then, right? So if the real number was 76, our scientific notation would be 7.6 times 10 to the 1, because you must multiply 7.6 by 10 one time in order to get 76. And you can also have 10, you can also have 10 to the power of negative something, which would just be dividing by 10 instead of multiplying by 10, as with when we have 0.18. So because we must have one number in front of the decimal place, we have 1.8 times 10 to the negative 1, because 1.8 divided by 10 equals 0.18. Okay, next slide, please. Okay, float, like I said earlier, holds numbers. Float can represent any real number. Its range is from 3.4 times 10 to the negative 3.4 times 10 to the 38, all the way to 3.4 times 10 to the 38. So this is like way above trillions and like quadrillions and whatnot. This is like a really, really big number. Oh, something I probably forgot to mention earlier, but I'll mention right now is that why there's so many different types of number data types, like double, int, float, whatever, right? Is because each one can hold only a certain size number. So if you look right here, float holds a different size, float's range is different from double. The maximum number a float can hold is smaller than the maximum number a double can hold. So that's the difference between these like number data types. They have like a different maximum and minimum range. Okay, so double's range is negative 1.7 times 10 to the 308, all the way up to 1.7 times 10 to the 308. So double's maximum value is like 10 times float's maximum value. Well, it's more like 5 times actually. Actually, no, sorry, my bad. Not 5 times. It's like around 10 times. Yeah, on most new compilers, data type doubles and long doubles are same. So yeah, you don't really need to know long doubles that much. You just need to know double is probably like the largest number data type there that exists basically. So if you want a super big number, you should probably use double. Next slide, please. So maximum number of significant digits, decimal places for float values is 6 or 7. Maximum number of significant digits for double is 15. Precision is just maximum number of significant digits. So basically what this is saying is after your decimal point, how much numbers can you have? So if your variable was a float, then after your decimal place, you could only have 6 to 7 numbers. Whereas if your variable was a double, you could have 15 numbers behind the decimal place. Okay, next slide, please. Okay, wait. So that's the end of my computer science lecture. I have a look it for you guys to play. It's kind of like Kahoot. It's like a pretty short one. It's pretty fun actually. So I'm going to share my screen.
Okay.
Oh wait, you guys. So if you guys have played Kahoot, you probably know this. We'll go with time. We'll change this to like 2 minutes. Can I not change it to 2 minutes? Joining, use random names, lost accounts. Post now. Okay, so if you go to this website, lookit.com, you can probably just search up Lookit. It's kind of like Kahoot, and then you have to press play, and there's like a code right there. I'm pretty sure you guys have played Kahoot. If you haven't, well, yeah, just go on this website, type in this code, and you'll be able to join. And you can pick like your nickname and your like little animal character. Or you can just click this link I sent directly to probably join directly. Oh, really? The site can't be reached. Is the link not working, or is it like you can't go on the site itself?
Is it being blocked or?
Yeah, is the site like blocked for you, or is it like the link is not working? Simran, can you like specify a bit more? Okay, so like you guys are saying this site can't be reached. Do you guys mean like the site is like blocked? Like is this still not working? Oh, someone's in. Yay. Okay, well, Ganesh has made it work, so Ganesh, maybe you can share how you managed to get in. Ganesh, sorry if I'm mispronouncing your name, but maybe you can type in the chat how it works for you.
Okay. That's great.
It seems like someone else made it work. Simran. Oh yeah, more people joining. Okay. I'm gonna wait like another minute or two to see if anyone else can work. And yeah, whoever like Simran, maybe sorry if I'm pronouncing your name, but like if you guys found out how to make it work, maybe you could send it in the chat so other people also know, and maybe they can join too. You can tell people how you made it work.
Yeah, like in the beginning also take a bit of time for me to load it, so you might need to wait for a while.
How do you play this game? It's like Kahoot. You answer a question, and in this specific game mode I chose called Monster Brawl, and then you basically fight you get like an ability, and then you fight monsters, and you get XP, and then you answer more questions to upgrade your abilities, and basically you kill more monsters. It's pretty fun. It's like Kahoot but upgraded. So is anyone else still trying to join? If no one else is trying to join, I'm gonna start this game. Game ID is in the chat. It's 7286192. Okay, one more person join. Should I start the game now or wait another minute? Okay, more people join. Maybe I should wait.
Yeah, let's wait more minutes.
Okay. Maybe like whoever is okay, well, never mind. Okay, more people are joining. Yay. I can actually share. Seven people. Is that everyone now? Yeah, I know you guys are waiting for me. I'm just waiting to see if any more people are joining. Is anyone joining? If you're still trying to join, maybe like raise your Zoom hand or something. Or maybe send a message that you're still trying to join. Because I feel like people have waited quite a long time. I kind of want to start this game. It's fine if you don't join, but if you're still trying to join, just maybe send a message or raise your hand. Or like, should I start the game now? Or wait another minute? I don't know. Hey, Catherine, what do you think? Do you think I should start the game now?
You can start now, and I think people can still join.
Yeah, if you haven't joined yet, it's not working for you. Try clicking the link I sent and see if it works, or maybe ask someone else who made it work how they did it. I'll start the game now, and you can still join after the game has started. Yeah, just click on the link Catherine just sent. It might work. And yeah, you can still join after the game starts. Oh no, why is it 7 minutes? So yeah, it's 7 minutes, but I'll probably end it 4 minutes. 5 minutes. Oh yeah, we can't see what they're doing, but they're like fighting monsters. they got a rapid eggs.
I don't know if you have any question.
Oh yeah, you can't see me giving out the question because this isn't like Kahoot. It's a bit different. But from their end, they'll like click on questions and stuff. If they get it right, they get an upgrade. So you can see this person got a question right because they got an upgrade. You can't click on the link. Are you saying you can't click on the link? Then maybe like. I don't know how to solve it. So if you can't click on the link, have you tried searching up, look it, and going on the website and then pressing join now and then putting in this code? Oh, make sure I answer your questions. Oh, someone has killed a monster. Yay. Yeah, remember guys, if you once you kill the monsters, pick up the gems on the ground because that's what gives you points. There's like some people in the way.
In a half minute. Let's go, everyone.
Okay, yeah. Should I end this soon then? Because I can end it early.
Oh no, I think it's fine.
Okay. But you can actually just let this whole time pass. Because there's like roughly 3 minutes left. Because if I'm taking up too much time, I can end this.
On page 230.
Alright, 2:30. Okay, gotcha. How can I play? What do you mean? How can you? How can you play? You just finish Ganesh. Just answer the questions, and then you get an upgraded ability, and then you kill the monsters and pick up the gems they drop. And that's how you get points. And then you answer more questions and get more abilities. Okay, I'm gonna.
Okay.
Hey, I ended it early. Ooh, third place. Third place. Man. First place. Good.
Great
Nice.
job.
Congratulations for winning. You guys think that was pretty fun? Yeah? No? Okay.
You guys like this game? Or do you guys have any other game? Do you like Kahoot, Gym Kid? I don't know. Oh,
One, it's in the Zoom. Ganesh. I'm sorry if I'm butchering your name, but yeah.
okay. Let me type chat.
So yeah, Yeah, so that's Book It, guys. They have many different games too, not just one of them. They also got like a variety of games. So next time maybe I can run a different game. Just yeah. But yeah, just Book It is just basically Kahoot plus games. It's okay if you don't know how to play. You'll know next time. Everyone's probably new to this the first time.
Yeah, the first time I played this is I don't know what I'm doing. Like the monster just coming out. Yeah, we'll get better next time. Okay, so feel free to type more questions you have in the chat. And now we are gonna move on to history. And do anyone from history want to share their screen? Wacom, are you available of sharing screen? Or I can.
I don't know, maybe.
It's okay. I think I can share it. Okay. Shoot. Okay.
All right, so the person I chose to do was Galileo. He's an astronomer, mathematician, and philosopher. I chose him because I saw that you guys were interested in astronomy, so I picked someone who was involved in that. Next slide. Okay, so he was born in Pisa, Italy in 1564, so around 500 years ago. He first planned on studying medicine, but then became really interested in mathematics and philosophy, so he decided to go teach that. He did not get a university degree, even though that he seems really smart. And then he decided to study motion, and so like the physics of motion for the next few years. Next slide. Okay, so some of his achievements in astronomy was that he improved the telescope. This allowed him to see like magnify up to 20 times instead of before it was only 8, which allowed him to see the surface of the moon and how it really looked, which was rough and bumpy and full of craters and not smooth like how they thought. He also discovered how Saturn looked and like the rings that surround it. He came to the conclusion that the sun was the center of the universe using this telescope and studying the motions of Jupiter's moons. So he wasn't the first person to think that the sun is the center. It was actually Copernicus. It's just that he was the one who, yeah. If you have questions, you can just ask. He was the one that provided more evidence to show that. Next slide. So because he started to believe that the sun was the center of the universe, this did not agree with what the church thought at the time. So the church deemed that he was heresy or he was heretical, which meant that he was like trying to bring down the church. So the church ended up banning him. They didn't allow people to teach or defend the Copernicus theory that where the sun was the center of the universe, because they believed that the earth was. Next slide. So after he got banned, he got like sentenced to life imprisonment, but he didn't actually go to prison or get tortured or anything. He just stayed in his house most of his time, and he just did more studies and wrote more books about motion and like projectile motion. Yeah.
Who is thinking about Voltaire?
I think whoever made that slide isn't here right now. I guess I'll do it. Voltaire is an Enlightenment philosopher, historian, essayist, playwright, storyteller, poet, philosopher, wit, and pamphlet leader, wealthy businessman, and practical economic reformer. So it seems like got a lot of things going for him. Next slide. Born Frank, not even going to try to pronounce that name, on November 21, 1694 in Paris. He wrote witty verse mocking the royal authorities and probably was imprisoned in the Bastille for that and for 11 months. Another dispute in 1726 led to exile in England for 2 years. On his return to Paris, he staged several unsuccessful dramas in the enormously popular Zaire. He wrote a life of Swedish King Charles the 12th, and in 1734 he published Philosophical Letters, a landmark in the history of thought. It which denounced religion and government, and this caused him a scandal that forced him to flee to Paris. He took up residence in the palace of Madame du Châtelet, with whom he lived and traveled until her death in 1749. Next slide. In 1750, he went to Berlin at the invitation of Prussia's Frederick the Great. 3 years later, he had a quarrel with the quick king, and he left and settled in Geneva, Switzerland. After 5 years, his strong opinions forced another move, and he bought an estate at Berny, France, on the Swiss border. Voltaire returned to Paris on February 10th, 1778, to direct his play Irene. His health suddenly failed, and he died on May 30th. So some important ideas of his was freedom of speech, freedom of religion, separation of church and state, which is basically just the fact that religion and government should be completely separate things. Also criticized Christianity and slavery, and he was one of the most important French writers in history. Montesquieu, also another Enlightenment philosopher. Born Charles Louis II on January 18th, 1689, near Bordeaux, France. He was educated at the College de Juilly and studied law at the University of Bordeaux. When his uncle died in 1716, Charles Louis became the Baron of Montesquieu. In 1721, Montesquieu published his first book, Letters Persiennes, which is Persian letters, which made fun of the French government and social classes. Following year, he went to Paris and he moved in court circles. And in 1728, he became a member of Académie Française, a prestigious intellectual society. Baron is basically a type of noble, so basically probably just someone who's really rich. In 1748, after years of work, L'Esprit des Lois, the Spirit of Laws, was written. To Montesquieu, abuse of power, slavery, and intolerance was evil. His book reflects his idea that government can avoid these evils by separating power into executive, legislative, and judicial branches, by governing with honor rather than through fear, and by upholding human dignity. He died in Paris on February 10th, 1755. Important ideas of his was separation of power into executive, legislative, and judicial branches, which was also implemented by the US Constitution, which is used today. The president is executive, Congress is the Senate and House of Representatives, which is legislative, and the Supreme Court is judicial. Okay. Here's Napoleon Bonaparte. He's a French military general and was once Emperor of France. Next slide. Early life and rise to power. He's born in Corsica, France in 1769 and attended a military academy and became an army officer in 1785. So he became army officer when he was only like 16 years old, so very young, probably really good. During the French Revolution, he sided with the revolutionaries instead of the previous rulers. If you don't know, the French Revolution is basically a war. It was basically like the lower classes being oppressed and bullied by the upper classes. So they declared war on the upper classes basically and tried to take over. After a coup or military takeover in 1799, he made the French government a military dictatorship with himself at the top. Achievements. Once he was in power, he implemented the Napoleonic Code, which was a reform of French laws. Also fought in the Napoleonic battles, which was a series of wars from 1799 through 1815, which is basically himself and the French against a large alliance of several other European powers and nations. He also declared France as an empire and himself as the emperor. He was an incredible general. To this day, he's considered one of the best in history. And throughout his career, he fought more than 80 battles and won almost all of them, losing only 11 times. Fortunately, his death, he invaded Russia with a massive force of 600,000. But unfortunately, because of the weather conditions, it's like super cold there and it was winter. So basically his entire army was killed. And then when he tried to flee, he was met with the powerful military alliance and lost to them as well. After the loss, he was forced to step down from emperor and he was exiled to the island of Elba in 1814. In 1815, though, in 1815, though, he came back, established himself as emperor again, and still lost again as well in the Battle of Waterloo and exiled to St. Helena, where he died 6 years later in 1821.
So I did Leonardo da Vinci, which is an artist. So his early life, he was born April 15th in 1452 in Vinci, Italy. And he was the son of a prominent attorney notary, which is like a noble, and a young peasant girl, which is not a noble. And he was raised by his father, Sir Piero, and several stepmothers, since his like biological mother didn't have very much wealth. His early years are spent living in his father's estate in Vinci, and he was heavily influenced by his uncle who loved nature, and it's said that he had a hand in rearing him towards his formative years. He really didn't receive much of like a formal education. He just had like the basic reading, writing, and mathematical skills. And as soon as his potential for an artist was recognized, his father sent him at the age of 14 or 14, around 14 or 15, to an apprentice with the sculptor and painter Andrea del Verrocchio of Florence. His achievements are so he was a Renaissance man, and he was an artist and an engineer, but he's most well known for being an artist. His greatest work is the Mona Lisa, which I'm sure all of us have at least heard of or like seen before. And it's argued to be one of his greatest artistic achievements. His other great work is The Last Supper, which is on the bottom here. And then finally, his drawing of the Vitruvian Man has become a culture icon. And so like everybody's kind of seen this drawing of this man. So yeah.
Okay, we have math next.
Okay, I guess I'm back to teach math again. I mean, not again, but like to teach. Okay, so yeah, so currently we're kind of unsure what math level you guys are on right now, so we decided to first start off with some like intermediate geometry. So this is 3D shapes of volumes part 1. So in my opinion, just like there's like many different 3D shapes, but there's like 6 important ones or 6 most important ones. The first one is a cube. To find the volume, you multiply length by width by height. So for a cube, the length, width, and height are actually all the same because all the sides of a square are the same, and therefore all the sides of a cube are the same. So I draw some lines. Yes, okay. So this could be height, this could be length, this could be width, but they're actually all equal because if you know like a square, all 4 sides are equal. Okay, so rectangular prism is next. This one is basically the same as a cube. It's also length times width times height. The one difference is that rectangular prism is made out of 2 squares. You can see on the 2 ends and 4 rectangles. So normally this is actually the height. The rectangular prism is kind of on its side right now. Length, and then this one's width. So the length and the width make up the square base, and then you have the height, which is how tall the rectangular prism would be if it's like standing up. And length and width would be the same because the bottom is a square, but the height would be different because if it was the same, it would no longer be a rectangular prism, but it would be a cube now. Okay, triangular pyramid. This is just like a standard pyramid maybe you guys have seen. The base is a square, and then it's also made out of 4 triangles surrounding, on top of the square. So the area of a triangular pyramid is 1/3 or like 33% times the base times height. So the base this time is length times width again, and that would give you the area of the base, which is just a square. You take 1/3 of that and you multiply it by the height, which is how tall the pyramid is. And that would give you the volume of triangular pyramid. All right, you guys all know what volume is, right? If you guys don't, volume is how much mass or like things a container can hold, I guess, so to speak. So it's like basically just the area inside of these shapes. That's like your volume, or like, yeah. Hey, next slide, please. Okay, next is a sphere, which is also just basically a ball. So I'm pretty sure most of you guys know how to find the area of a circle. You take the radius, which is half the diameter of the circle. The diameter of the circle is just the length from one side to the other. That would be the diameter, which I'm like D. It's a bit laggy. Okay, it's fine. Radius is just half of that. Basically, radius is how the length from the center point of your circle all the way to the edge of your circle. So how do you find the area of a sphere or a ball? You take 4/3 or 4/3 times pi times the radius squared. Okay, so radius is already shown here. You square the radius, basically you times radius by itself, and then you multiply that by pi. If you guys don't know what pi is, it's like it's a constant, or like it's this, yeah, it's a constant. It's always 3.14 and then like a million numbers afterwards, but the most important ones are 3.14. So you just need to know that pi is basically 3.14. Okay, let's see. Okay, next is cone. How do you find the area of a cone? This one is, or no, not next slide. Cone is basically the same as the triangular pyramid from earlier. You take 1/3 times the base times the height. The one difference here is that the base is no longer a square, it's a circle. So instead of doing length times width for the base, you do radius squared times pi for the base, because that's how you find the area of the circle. Radius squared times pi. Okay, that's not a good times. All right, so the yellow thing right there is how you find base. Cylinder is even simpler. It's just base times height, and the base is a circle, so you do the same thing again. Radius squared times pi. Okay, next slide, please. Okay, and someone
I can
else is
go.
going to present the rest. So, yeah.
So the next topic we have is like triangles. So again, we're like kind of unsure of what you guys really know about these topics. So I'm just gonna like start with the basics and get like a little bit harder. But first things first, like triangles, these are the types of triangles. By side, there are three types: the equilateral triangle, the isosceles triangle, and the scalene triangle. An equilateral triangle means that all three sides of the triangle are equal in length. An isosceles triangle means that two sides are equal in length, and the third one can vary. And finally, the scalene triangle is basically any type of triangle that doesn't fit into an equilateral or an isosceles triangle. And then there are three more types by angle. There's an acute triangle, a right triangle, and an obtuse triangle. An acute triangle has three angles that are less than 90 degrees. A right triangle has one angle that is exactly 90 degrees, and an obtuse triangle has one angle that is greater than 90 degrees. Next slide. So next we're going to go over like some common rules. I think these are the most common that we like use in like mathematical equations. So the first one is the right triangle rule, and it's called the Pythagorean theorem, and it is basically as shown by the diagram. So A is one side and B is another side, and C is the longest side. So A and B are always shorter than C. Both of them are always shorter than C, and C is always the longest side. And basically what the rule says is it's okay. The side A, if you square the side A, which is basically doing A times itself, so A times A, and you add that to the square of B, which is just B times B, then you would get A squared plus B squared, and then you would, if you root it, then you would get C, the value for C. And this is like a super common rule. I feel like we use it all the time, so it's good to kind of know. And then the second two are they're more like memorization, I would say, and they derive off of the Pythagorean theorem. So the first one, so they kind of come off of that. And the first one is an isosceles right triangle. This is a little bit more complicated, but these two triangles have the sides of, or like they start with the side 1. The reason behind that is because they're actually based off of a unit circle. And I think we're probably going to get into that in a later lesson. But just know that is why we have the numbers 1. They're just most easy to understand off of the unit circle, and they're most easy to understand off of this triangle. And it's easiest to apply if you have the number 1. So the first one is an isosceles right triangle. And if it's an isosceles triangle that also has a right angle, it means that two sides are equal and there is a 90-degree angle. And as you can see in this other photo here, always in a triangle, the angles will add up to 180 degrees. So if you do 180 minus 90 divided by 2, then you can get the other two angles. And the property of this is basically the sides are always proportionate with 1, 1, and square root of 2. So if the isosceles triangle, if the equal sides were equal to 2, then it would be 2, 2, and 2 root 2. And it's the same concept for the 30, 60, 90 triangle, which I honestly think is used more often. But again, the first side that we start with is always 1, and it's also like a proportional rule, and it's the angle or the side that's touching the right angle on the 30 degrees is root 3, the side that's the longest is 2, and then the bottom side is 1. And then again, the angles of a triangle always add up to 180 degrees. Just always remember that. Okay, next slide. And then finally, we're going to get into a little bit of trig. I don't know if you guys have learned this before. So if you guys already know this, we can go into like the more complicated parts of trig. But these 3 are the most basic and honestly the most common used as well. They kind of fit into every other category that you're going to learn about. So first things first, in a triangle, there's the hypotenuse, the adjacent, and the opposite. And you basically decide these length or these sides based off of the angle. So we have angle, the angle alpha here, and like as you can as represented by this like symbol, and opposite is the side that is opposite from this angle, and then adjacent is the side next to the angle, and then the hypotenuse is always the longest side on the triangle. So if anything, if you like forget anything, always remember hypotenuse is the longest side of the triangle. And then for each of the sine, cosine, and tan, they use these 3 sides to create an equation. And so sine of theta is the opposite over the hypotenuse. So it's the angle across, it's the side across from the angle and the longest side. And then cosine is also using the hypotenuse, but it's the adjacent. So it's the bottom line, the one next to it, over the hypotenuse. And then finally, tan uses the opposite and adjacent rather than the hypotenuse. And it's the one that is across from the angle over the one next to the angle. Hopefully that makes sense. If you guys have any questions, just like leave it in the chat and I'll answer as best.
Okay, sorry everyone, we are a little bit over time today, but thank you all for staying behind today. So feel free to still type any question you have about math, history, or programming in the chat. Our tutor will still stay behind for a while. And then like last time, it would be great if you guys can take a few minutes to finish this Google form for our feedback. You don't have to do it now, just do it sometime today if you have time. And yeah, that is for our today's class. You all feel free to leave now and have a great day.